attended a lecture on the physics of baseball presented by Dr. Alan Nathan from the University of Illinois. I've always loved watching baseball, and I always think it's really cool whenever we get to apply the things we learn in class to real-world situations. So I found Dr. Nathan's talk really neat. So Dr. Nathan highlighted two main points in his discussion about the physics of baseball. The first deals with ball-bat collisions, and the second deals with the flight of the ball when pitched. So talking about ball-bat collisions, a ball loses about half its speed when it hits the bat. This is due to a transfer in momentum. Now, the bat also slows down, and that's because although the momentum of the ball gets transferred to the bat, the two have momentums in different directions, so it causes the bat to slow down as it travels in the opposite direction. There's also an equation that relates the speed of the batted ball to the speed of the pitched ball, the speed of the bat, and something called the collision efficiency. When it comes to the velocity of the bat, it's actually more important by like a factor of 6 than the speed of the pitched ball. And you can kind of see this intuitively when you bunt a bat versus when you swing it. It has a pretty big effect on the speed of the ball. And then the collision efficiency, it depends on two things: the weight of the bat used, as well as something called the coefficient of restitution, which kind of deals with the bounciness of the ball. So if you're wondering what the difference between wood and aluminum is in terms of how fast the ball can go, they actually are about the same, just because their differences in weight balance with their differences in coefficients of restitution. It's also interesting to note that it does matter what part of the bat you hit the ball with. There's actually a sweet spot on every bat that when you hit it there, it reduces the vibrations of the bat and it causes the ball to go the fastest. So moving on to the flight of the baseball, when a ball gets pitched, there are a couple of forces working against it. The drag slows it down, and then something called the magnus, which refers to the spin of the ball, as well as gravity, deflect the ball from like going in a straight line. Still, with these effects, normal pitches have pretty predictable movements. Like you can, from when you pitch it, you can kind of guess where it's going to land above, or where it's going to fly above the plate. But when it comes to something called the knuckleball, you really have no idea of knowing where it will go over the plate. And that's because its trajectory depends on the number of revolutions the ball makes, as well as its axis of spinning. Dr. Nathan actually has a really cool lab with a wind tunnel where he studied the knuckleball. It's basically a chaotic system, so like one small change when you release the ball, when you pitch it, can cause a really big change by the time it gets to the plate. And then one final note about the flight of the baseball is that balls actually travel faster in lower pressures, which explains why there are more home runs in the Rockies baseball field up in Colorado. So I was really impressed with Dr. Nathan's lecture, and he encouraged us to go onto his website, and I did. And I found a really neat research paper on there from another professor from California State University. David Kagan talked about the kinematic model behind the physics of stealing bases. So he actually developed a model for the most efficient way to get from base to base. So I thought that was cool. And then I was also inspired to think about the physics behind other sports, not just baseball. And so I thought about my favorite sport, Quidditch. And for those of you who don't know, it's like a magical sport in Harry Potter. And I went online and I found a very reliable website called fanfiction.net, where a very nice man whose username was Mosh Pit Stories explained to me that basically Quidditch is physically impossible, because if you are traveling at speeds of 150 miles per hour and you try and catch a snitch, it would go straight through your hand. It'd be like driving 150 miles per hour, sticking your hand out the window and trying to catch a golf ball. Like, it would just go straight. It would be bad. And that's also not to mention the amount of pressure that would be exerted on your groin area when you're sitting on a wooden stick going at those speeds. It's just, no. So obviously there's got to be more than physics involved in order for Quidditch to be a real sport. Magic is the most obvious answer that comes to mind. But yes, thank you for watching my video, and I hope you learned something new.